Okay, so we're going to talk about the periodic table. This is for PreAP. Let's go over. So we learned that Dmitri Mendeleev first arranged the elements into 7 groups with similar properties. He arranged the elements according to increasing atomic mass. Later on, Henry Moseley rearranged the elements according to increasing atomic number. That's the one we use today. That will be a test question, so make sure you memorize that. General periodic table layout. A period goes left to right. These are our rows. A period goes across. Notice there are 7 periods or energy levels. There are 7 periods. Each period represents an energy level. With that being said, there must be 7 energy levels. A group or family goes up or down. Okay, so let's look at it. We have 1, 2, 3, 4, 5, 6, 7 periods. Remember, we end a sentence with a period. And we have 18 all the way across, 18 families or groups. And remember, a family is like a family tree, and trees are upright. So those are our columns. Just ways to help you remember it. Okay, so there are 18 columns. So the periodic table is divided into metals, nonmetals, and metalloid. Okay, so metals are on the left and nonmetals are on the right of the staircase. Metalloids are on the staircase with the exception of aluminum, which is a metal. So here we have our periodic table. Here's our staircase or our zigzag line. Here's our metalloids that we have circled. Oh, I'm so sorry. Here's our metalloids that we have circled. Here, aluminum is not circled because it's a metal. Remember, it's the most abundant metal on Earth. Metals represent 75% of all known elements. Characteristics: they have high malleability, many are ductile, most have high thermal and electrical conductivity. They're solids at room temperature with the exception of mercury, which is a liquid. Now let's look at the periodic trend. So we have, as we go to the left, the metallic properties increase as we go to the left. So the more malleable elements are here, these alkali metals. Okay, we often think that iron or copper is the most metallic, but it's actually the most malleable and the most conductive elements are here, the alkali metals. Okay, so then nonmetals exist in many colors. They can be found as solids, liquids, and gases at room temperature. Many have allotropes. Remember, we discussed an allotrope exists naturally in 2 or more forms with different properties, such as a graphite, like your pencil lead, and a diamond. Hydrogen is considered a non-metal despite its location. So hydrogen does not belong to a family, but it has 1 electron in its outer shell, so it is here on top of group 1A. Now metalloids have characteristics of both metals and nonmetals. They are like metals in that they have high luster and electrical conductivity. They are semiconductors. They are like nonmetals in their crystal structure, meaning that they're brittle and not malleable. Remember, brittle means easily broken. Now let's talk about the representative elements, the A's. The elements in groups 1A through 8A are called the representative elements or the main group elements. Okay, we have group 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. Hydrogen ion charge is either +1 or -1. It is the most abundant element in the universe, not on Earth, but in the universe. It does not belong to any family. The alkali metals, group 1A or group 1 here, are going to consist of lithium, sodium, potassium, rubidium, cesium, and francium. They have an ion charge of +1. This means that all elements in group 1A have lost an electron. These elements are lustrous or shiny. They're soft, silvery solids, extremely reactive. They're usually stored in argon or oil. They're never found uncombined in nature. They react explosively with water, and this group is considered to be the most reactive metals. Alkali earth metals are group 2A or column 2. They are beryllium, magnesium, calcium, strontium, barium, and radon. The ion charge is +2 here. They are very reactive, but less reactive than the alkali metals, and they are also never found uncombined in nature. The boron family, group 3A or group 13 here, is boron, aluminum, gallium, indium, and thallium. The ion charge is +3. This means that all elements in group 3A have lost 3 electrons. This group is made up of 1 metalloid, that's boron, and 4 metals. The carbon family is going to be carbon, silicon, germanium, tin, and lead. The ion charge is ±4. This means that all elements in 4A have lost 4 electrons or gained 4 electrons, depending on if it's above or below the zigzag line. The nonmetals, the 2 nonmetals, are negative, meaning they have gained electrons, and 2 metalloids and 1 metal. Remember that carbon is present in all living things. The nitrogen family is in group 5A, or group 15. This is nitrogen, nitrogen, phosphorus, arsenic, antimony, and bismuth. It has the ion charge of -3. This means that all elements in 5A have gained 3 electrons. This group is made up of 2 nonmetals, 2 metalloids, and 1 metal. Remember, nitrogen is a colorless, odorless gas, and it comprises 78% of the air. Our oxygen family is group 6A or group 16. Oxygen, sulfur, selenium, tellurium, and polonium here. Okay, has a charge of -2. This means that all elements in 6A have gained 2 electrons. This group is made up of 3 nonmetals and 2 metalloids. Scratch this out. Oxygen is an odorless, colorless gas at room temperature. Oxygen is very reactive and combines with almost every element. Oxygen is produced in photosynthesis and is needed in combustion. So remember, is our photosynthesis reaction. Carbon dioxide plus water and sunlight gives me glucose plus oxygen. Halogen family, group 7A, very, very important family here. Group 7A or group 17, fluorine, chlorine, bromine, iodine, and astatine. Ion charge is -1. This means that all elements in 7A have gained 1 electron. This group is made up of 4 nonmetals and 1 metalloid. Each has a distinct color, odor, and is a gas. Only family that has elements that are in solid, liquid, and gas states at room temperature. This group is considered the most reactive nonmetal. These elements are reactive and exist as diatomic molecules. That means they are never found alone in nature. Di means 2, and atomic meaning atom. These will not be found just as 1 atom in nature. They are found in 2s. You must never forget these, therefore memorize these Brinkelhoff twins. That's bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. There are 7 diatomic molecules. And then don't forget hydrogen. Okay? All right, so I'm going to stop this here. And so that's the front of the pre-AP notes number 1. And I'll do the back as another lecture. So that way you can stop and just do 2 10-minute videos.